case?
It's like the absolute value. They split it up at 0.
So could you split it up from negative infinity to 0 and 0 to infinity? Yes, but where else could you split it up?
Anywhere else.
Any other number that might be easier.
Because if you're thinking area, negative infinity to positive infinity, if you split it somewhere and you're adding this plus this, isn't it going to be the same whole as if you split it here, this plus this?
Yes.
Or if you split it here, this plus this. Yeah, it's going to be the same whole.
What if you split it at discontinuity?
Yeah, exactly. Coming back. Entertaining, but they don't get it yet. Okay, so then coming back. Is it probably easiest to split it at 0? Yes.
Yeah.
What Jason is thinking is of the function, what if I have 1 over x? So what, oh, thank you, good job, great, but let's go back to that. So,
Oh, my word, that's undone.
because next period they need to not see how to do it and see if they can do it.
Oh, no,
Don't worry, they won't be able to. So, probably 2 people.
Wow.
20. Anyway.
Do you have a Jason in that class?
Okay, so, coming back. What if I was to give you the integral from negative infinity to infinity of 1 over x squared dx?
Split at 0.
Yeah, split at 0, no big deal, right? False. It's a big deal. False. Why is 0 a big deal? Because it's a discontinuity. But do you think we still have to be careful of 0 because it is a discontinuity?
Yes.
So we would split it from negative infinity to 0.
From 0 to 1. Oh,
Why wouldn't you?
But the problem
because
is,
I want to, Kyle.
can we keep it that way?
No.
No.
No. Because not only would we have to take the limit towards negative infinity and make that a, and the limit towards positive infinity and make that b, but guess what we have to do with discontinuities?
Make it C.
Take the limit. As you approach 0 from below, 0 from below, and 0 from above. Oh, it stinks. So guess what we have to do?
Split it up again.
How are we going to split it up again?
C.
Negative 1. Positive 1.
I was right.
From negative 1 to 1.
So I can do my negative 1 to,
0.
1.
Might be.
if we call this guy a, it'd be the limit as a goes to negative infinity, right?
C.
And this guy could be b, and we're taking the limit as b goes to 0 from below.
Yeah.
What would be next?
From B to positive 1 as limit approaches B from 0 to positive.
I don't like this.
No, it's a lot of variables. One more. 1 to infinity.
1 to infinity, which is can't be
Not
infinity.
infinity, so it's going to be,
C.
wait,
Okay, we used A, B.
oh, you used b twice, okay, so then c. Don't worry.
It's a lot of variables.
Okay, pause, consider, why does this make sense?
He's putting up a 0.
I can't plug in infinity to an integral, I need to take a limit, so therefore I have to establish that a approaching negative infinity. This function has a vertical asymptote at 0, so I can't plug in 0 to the antiderivative, which would be 1 over x, yeah, the end fun. And even if I could plug into the antiderivative, I still have to consider the discontinuity. So then I had to establish the 0, but I'm coming from all the numbers lower than 0, so I have to go 0 below. And then I have to go ahead and go from my 0 to the positive numbers, so then I'm going limit 0 from above. And then I'm trying to make my way to infinity. So what made this so bad? I had a negative infinity bound, a positive infinity bound, and a discontinuity in between. How often does that happen? Not very often.
What if there's
But multiple discontinuities and I'm just being mean. Anyway, let's come back and make sure this makes sense.
If you're approaching 0 from the left to the right, why can't you put 0 because you're not reaching 0, you're approaching 0?
The limit notation wouldn't make sense if I didn't have a variable that was getting closer and closer. Does that make sense? So the idea, the limit does encapsulate the idea of the area from 0. Does that make sense? Now, question, could I change this to be negative 3?
Yes.
How about negative pi?
Yes.
How about negative e, negative 10, negative a million?
Yes.
It doesn't matter. I just needed something in between negative infinity and 0, right? And similarly on the other side. Cool?
So whenever there's a discontinuity, you have to do like that center step. Okay.
If the discontinuity is within the bounds. What if I was trying to find the integral of ln of 3x from 2 to infinity?
Doesn't matter.
I don't care about the 0, it doesn't really matter. Same thing if I was doing the integral of 1 over x squared from 2 to infinity or 1 to infinity. I don't worry about this. So only if it's included or is a bound. Include within the bounds or is a bound. We called this one yesterday endeavor number 11, right?
Yes, ma'am. Number 10.
11.
10.
Slide 12.
No, slide 11.
There we go.
Oh, wait, no, slide 11, number 10.
Yeah, okay, right? Don't write slide 11. Okay. Endeavor number 10. Gracias. So, wait, didn't we already solve this one? Your face.
Whoa.
Oh, we didn't. Okay, ready, set, go. For those of you that can't see it, I apologize. It is the integral from 1 to positive infinity of 1 over x dx. Similar to our first example, but different. Similar, but different. Go. Not as bad as the one on the board, I promise. If you want to make a bad one and go for it, you do it.
Jason and
If you want to make it, and you do it, and not make me do it.
That's what you call the snowball. Everything just gets
Maybe we'll be super focused on the problem and not be distracting.
Can we make an extra credit problem for the time?
What? No! Because then we'll know how to solve it.
Because the thing is, I just thought of one that has at least 2 discontinuities. What is it? 5.
Why would you do that?
I wouldn't make this credit question, but
They make it hard.
Yes.
That's a pretty good extra credit problem.
How do I find B?
We can have them both make extra credit problems, and then we can give half the class one, half the class the other, and make it each other.
Or they make the extra credit problem and they don't get the extra credit.
Why can't you do that? It's true.
That's what I'm thinking, exactly, we all let us do it. You got a problem?
Because.
Hey, you guys finished?
My face. I didn't do it. Hey, Luke. Sit to my face. Prove her wrong. I forgot. I'm just gonna. As it is.
Yeah.
Will every improper integral stabilize towards a constant? No. Converge? No. So what's interesting about this? Didn't we find yesterday, compared to, well, pause, sorry, I apologize. Any questions on the solve? Why does ln of b as b go to infinity, infinity? What's ln do? How long does it take to increase? You remember like the illustration of the exponential versus logarithmic growth? It takes, yeah, it'd be ridiculous. It takes ridiculous amounts of time to increase, but it does increase. So here's the struggle. What was the example that we did yesterday? We solved one yesterday at the very beginning. What was it? The integral from 1 to infinity of 1 over x squared. Question, what does the graph of 1 over x squared look like from 0 to infinity? So let me go ahead and throw this in. Let's do 1 over x squared. Yeah. Did it still not work? My window, I'm going to have it start at 0. Okay? Alright, hold on. 1 over x squared, what's it look like? Oh. Swoops down, right? Well, I'm only going from 1 to infinity. Yes. Pause. Let me prove a point. Remember I told you second semester, you can't always say it makes sense, so therefore it's right? Yes. This is a huge life lesson. Looking at my 1 over x squared. If I was to look at the area under that, it would all be shaded, right? From 1 to, and I could make an integral and I could at least symbolize it. It wouldn't be super great, but if I was to do 7, I could do my whole window, which would be 1, because we're not starting at 0, starting at 1. 1 to 10, it'll shade everything. Okay. So it's all of that, and it keeps going forever. Did that converge?
Yes.
What was the answer to the improper integral for our first example?
1.
1.
What, oh, we're talking about the first.
So if I was to go, now it's 0.9, if I was to go from 1 to 100, 1 to 1,000, 1 to 1,000,000, what's going to happen to this?
0.99.
No. Okay, stabilizing the
What
1.
Noah was teaching.
Now, what's interesting about, if I change the function, instead of being 1 over x squared, let's make it 1 over x. Is that a huge difference graphically?
Yeah.
No.
No.
Sure doesn't look like it. If I was to do the integral from 1 to 10 again, does it look that different?
No.
Nope.
It's a bit higher, but it doesn't look that different, does it?
Like a second function.
If I was to go from 1 to 100, 1 to 1,000, 1 to 1,000,000,
Bigger and bigger.
it's going to get bigger and bigger and bigger, but very, 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 very slowly. What's so interesting about the difference in the answers? First one stabilizes, the second one doesn't. The question, guys, how different are their graphs?
Not very different at all.
Not much at all. So if you're trying to argue to someone why, without using calculus, without using antiderivatives, just using the graphs themselves, why the infinite area of one exists and the other doesn't, would that be kind of difficult to do?
Yeah.
Could you argue someone into, if they believe the first one, could you argue them into understanding that one if you weren't to use calculus?
No.
No.
No? You sure?
At least with the capacity of mind. So can you
If they believed that the integral from 1 over x squared stabilized to 1, if they believe that wholeheartedly, they're like, okay, I get it, done. Without using calculus, could you explain to them erroneously that 1 over x is super, super similar, so therefore it's going to be the same?
Well, yeah.
Totally make them believe that, right? Because they're taking a solid fact and then you're looking at something super, super similar and you're able to be like, oh yeah, of course, it makes sense, because the calculus showed otherwise. And similarly, if they were to totally believe that this one cannot exist, could you pretty quickly convince them that that one doesn't exist also?
Yeah.
They're so similar. But the struggle is, can you just go off the visualization? No. You have something deeper, something truer, something, ooh, that we can actually
The
prove.
meaning of life itself.
42? The actual truth of what's going on. Anyway, guys, this is just introducing the idea of how two very, 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 very similar functions can behave very, 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 very differently. And we have to be careful because we are so used to being like, oh, they're both concave up, they're both decreasing, oh my goodness, they're both basically the same. Are they? No. And so we have to be able to have proof behind what we're going to say as far as when something converges and when something diverges. It can be the smallest difference that makes, well, the smallest, I ruined it. I can't think of another way to do it. I can't think of a synonym. Can you think of a synonym for difference? The smallest distinction? The smallest distinction can make the world of difference. Anyway, I was trying. We've only talked about, though, technically, thus far, we made a forever card with the infinite bounds. But do you guys understand what's going on when I show you technically the notes for discontinuity, since we already talked about it? Right? If we have a discontinuity of B, we're going to have to split it at B and come from below and above B. So I'm not going to make it forever, sorry, I'm not going to make an endeavor out of it because I believe it is so similar to the infinite bounds. Just instead of extending to infinity, the function is going to infinity towards those vertical asymptotes, or technically any discontinuities. I have to be careful. Coming. So you guys can write them, but let's not make an endeavor out of it, just because I think it is so similar. Just be careful. If there is a discontinuity at an upper bound, I'm going to have to come from below it, right? And if there is a discontinuity at a lower bound, I'm going to have to come from above it. Now, up on the board, we came from either side, so it made a lot of sense, but just be aware, if you're only coming at it from one direction, you have to come from it, or from the correct direction as the bounds indicate. Thanks, bud.
I did not write it down.
Like today?
I appeal to you, therefore brothers.
Got it?
No. Misty, I'm like one of the slowest writers. I'm really sorry. I'm gonna fail college.
You might have to have a reporter.
Am I allowed to?
Some classes, yes, you need to ask the professor.
Miss D, they're keeping secrets from me.
That's pretty messed up, Trina.
Mama knows what they're talking about.
What is wrong with our class?
You guys were talking about their extra credit problems, but I might be wrong.
Fake friend. Bad.
Is that a thing, fake friends? I don't think that's a thing. How about now, we ready?
No. Let me just take a picture. Discontinuity.
On the last one.
Basically, the word discontinuity is just really like messed up.
Can't you just do discount? Or discon?
That's what I do.
Or dis? No, don't do dis. That just, I don't think it's the idea, class.
I abbreviate way too much.
Continuity. How about now?
Misty,
I'm just gonna take a picture.
Put my phone's acting up.
It's okay, mine's been acting up all day.
And I haven't even updated it.
Me either. Maybe they're getting mad at us because we're not updating.
I haven't updated in forever.
Okay, how about now?
I took a picture, so I'm looking good.
But as you guys are writing, you're realizing that you could have to split up in between and come from either side, or it might be at one of the upper or lower bounds, so you only need to take a limit towards one direction. Guys, number three is not ready to go yet, right?
Nope.
Because number 3 just says, oh, you gotta split up at that C, and then what would you have to do?
Limits.
Do each of 1 and 2 applied.
Okay, now we're good.
Each of 1 and 2 applied. Okay, couple people still writing?
Can I get some water?
I have a picture of it, so if it's
It's up to you, John. You're a real one too.
So let me go ahead and let me see if I can dual screen. Do I have an example that's easy? Yeah. Okay. So if I was a dual screen, my example is evaluate the integral from 0 to 1 of the cube root, 1 over the cube root of x. You guys don't need me to set it up because there is a discontinuity for this function at 0. Does that make sense? Because the denominator, so here's what's getting tricky. They can give you integrals where the bound is the discontinuity. In AB, we never had bounds that were discontinuity, and we never had infinite bounds. Now, it looks like an AB problem, but it's definitely not, because the left bound is not going to exist, which means I have to take a limit as A goes to 0 from above, because the numbers from 0 to 1 are above 0, right? So then I have x to the negative 1/3 dx. Go. If you have not yet been going. I wonder what your calculator would do if you plugged in a discontinuity as a bound. Interesting. So as you guys are playing with that, let me see what your calculator, what error message it would give you. Because I am curious, and I honestly don't know. And my other curious people are too busy pondering other curious problems. Or still solving the problem at hand, which is a good thing. Let's see. 1 over the cube root.
Well, we can just say in survival, we don't have to say the solution.
You guys ready to see what it does?
Almost.
So I have the 1 over the cubed root of x in my function, in my y1. I have a graph, roughly has the same window up there. I'm going to go from 0 to 1, 0 being its discontinuity. Oh, it's frozen. What's it do? 1? Maybe it hasn't actually applied it to the, so it hasn't applied it to the function yet. Ooh, this will be fun.
Bless your soul, bless your soul.
Oh, yeah, it does it.
What? How did it do that?
It ignored it.
Did it go infinitely high at 0?
No.
Does the programming itself not actually solve for the antiderivative and plug in with FTC? Is the programming itself an actual approximation that's really, really, really precise?
Yep.
Whoa.
Precise approximation.
Our calculator does not even know the fundamental theorem of calculus. Silly little calculator. You guys added 1, right? Multiply by the reciprocal, yeah?
Yeah.
Rewrote it so it's easier to think about? Oh, my reciprocal. Thank you, thank you. I was too focused on my power. Then I have x squared being cubed rooted times 3 halves, and I'm going from a to 1, where my limit is as a approaches 0 from above. So then I end up with 1 gets squared underneath minus 3 halves times the cubed root of a gets squared. Limit as a goes to 0 from above.
Yeah, I missed the integral.
Hold on, pause. It's okay, I did too. What do you guys think? Pause. Is it right so far?
Yeah.
You're double checking me? Cool. This one's just going to end up being, well, it doesn't matter. That's just 1, right? And 1 times 3 halves is just 3 halves. True? Okay.
It's getting closer and closer to 0.
It's getting closer and closer to 0. 0.01, 0.001, 0.00000000000000000. What's this going to?
2/3.
0. 0.
Oh.
There you go.
Hold on. What did our calculator say?
1.499.
The approximation got close. But close enough?
No.
I don't think so.
Close enough.
I mean, I guess 3 decimal places, if you were to round and cheat, you might be all right on the AP, but
How
if you
is
needed
that
4.
cheating?
I'm not cheating at all. Anyway. Guys, can we say that the calculator will always be only 4 tenths, hundredths, thousandths, 10,000ths off, and it'll be all right? All right, special type of improper integral.
I'm special type of.
Miss D, will there be more notes after
Slide
this?
12.
After
Number
this slide?
Okay.
I just want to see if it's worth squeezing.
Yeah, that's a perfect.
It's totes worth.
Endeavor. Number
11.
12.
11.
11.
Slide.
Are you sure?
Yes. Stink, I still wrote it. It's 11. Slide 12.
11. Slide 12. I promise. I promise.
Have you ever met anybody?
I'll show it, I'll show it, I'll show it. Hold on. We gotta do what?
Have you ever met somebody with a Romanian accent?
My brother-in-law's Romanian, actually.
Whoa, does he have an accent?
Yes, but not super strong. Some people think it's strong, but he's pretty Americanized.
Wait, slide 11. That's so fun.
What? Katrina Kevorkian.
I had to prove that this was number 11 through science. And I can't do it.
Well, science is based on experimentation, right?
Observation, man.
An observation. So can't I just pull up the endeavors and we look at it?
But it has to be observed more than once for it to be true.
Okay, I'll open it.
Someone else pull it up on their phone.
AP Bio.
But that's for something that is ambiguous in its reading of results, right? Like,
Math.
I don't know. I'm not so sure about that.
No.
I just want to say this dude was on my side. Please.
Like, if you were to look up Avogadro's number, wouldn't you just use it, or would you make someone else look it up? Does that make sense?
Yeah.
What I said doesn't apply.
Oh no! Kiddos! I did make it an endeavor. I hope you fixed it.
Oh my gosh.
It was 11.
Misty?
Based on what we did in class, it was a 10.
Now I'm confused. Oh my gosh, Miss D! We said 11! We said it! Katrina, that's great. I just went.
Oh wait, that's the wrong one. So,
I know what we were saying.
7.18, right?
No, but when you was 11, we're not saying that it was 11.
Oh my god! So it was 11.
I don't even have words to say right now.
Katrina, I have never been more disappointed in my life.
I don't even have words.
Katrina, I'm not even I'm just like, we haven't done that one.
myself believe in myself. Believe
Hey, we're not totally off, because I didn't make it an endeavor card.
These are logical.
So it's 11.5.
What are your logical fallacies?
No, it's still off.
Alright.
This one's false.
These are the tricks. We've been ensnared.
What are we doing?
Drop it.
What's the number?
Okay, he's number 11, the improper integrals. This guy is not an endeavor card.
Yes.
And here's the reason why. There's something,
Here's not an endeavor.
no. This one's not an endeavor. It's actually going to come back in the P-series test. I think 2 years ago I wrote it twice in the cards and it confused people. So we're just going to write it once this year, meaning not right now.
Okay.
Wait until it comes up when we need it.
This?
However, we will use it. We will use it. And how can we use it? Even though we're not memorizing it yet. How can we use it?
That one doesn't have to go to 0, so that's fine. I'm looking at the examples. See?
Wait, that's not what we're asking. I'm not asking converging or well, I sort of am.
Are you telling us to solve?
Number one, I'm saying to solve.
Oh, yeah, then, yeah. You can integrate that.
But I don't need to integrate it. Okay, pause. According to the yellow highlighted box up above, does number one converge or diverge without even solving?
Diverge,
Why?
because it's less than 1.
Good. I'm a genius.
Oh, wait, I never read
It's equal to 1. I appreciate the humility.
Thank you.
This is all privilege.
So what would happen if you did integrate and you did take the limit as b goes to positive infinity of the antiderivative from 1 to b? It would be infinite. True. But I can go ahead and if you use this fact, whenever you have 1 over x to the p, you can solve it quite quickly. Might make things go a little bit faster. How about number 2?
It is
1/2.
So it's divergent.
Or 1/3.
No, converges.
It converges. It's greater than 1.
It's 1/3 times the integral from 1 to infinity of 1
Wait,
over x cubed dx. Which means it does converge, and what it converges to is
Yeah.
1/6.
Nope.
Oh, yeah.
Okay.
That's what I'm confused about.
What's my power?
E.
3. 1/2 times, you forgot about poor little 1/3 chilling out
No
there.
one cares about
He's not
1/3.
Well, it makes it right or wrong.
Only the AP.
How did we know P was 4 though?
How'd you get to 1?
Oh, so then the next one.
Oh yeah, how did you get to 160?
Because we were able to compare, since this is 1 over x to the p, we were able to use the power 3 and say the power 3 is greater than 1, so therefore this improper integral will converge to 1 over the power minus 1. And 1 over 3 minus 1 is 1/2, and 1/2 times 1/3 is 1/6. 1/3 times 1/2, 1/2 times 1/3 is 1/6.
1.
Number 3,
Converges to. Diverges to
1.
1.
pause.
Oh, no. It has to be, then it goes to 3. So it diverges. Diverges.
Why wouldn't it?
Because the 1 becomes a 3, right? Or no? Am I wrong?
You have to change something else.
Am I right? I'm wrong.
Pause. Right or wrong?
Wrong. Wrong.
If you take the area from 1 to infinity and subtract the area from 1 to 3, wouldn't that be the area from 3 to infinity?
Yeah.
So then I should be able to take this one according to my property up above and say the power is 2, which is greater than 1, so therefore 1 over 2 minus 1. That is going to be 1. But what do I still have to do? I still have to integrate and do the definite integral. Which, x to the negative 2 plus 1, that'd be negative 1 over x from 1 to 3. Which I could solve fairly quickly. Is it going to converge? Yeah.
Positive 1/3.
Because there are no more discontinuities. I've already dealt with the improper part. When I plug in 3, I get 1 minus a negative 1/3
So positive 1/3.
minus a negative, which will be plus 1.
Negative 1/3.
Positive
Positive 1/3.
1.
Positive 1/3.
Converge.
So converges, stabilizes, 2, 1.
Woo!
Is that a pretty cool little box?
Yes.
That it is.
Steve?
To be honest, I am making it endeavor.
Yes.
P series is something similar, and yet it doesn't have to do with integration or area under the curve. So I still think this is helpful. It can make things go a little bit quicker. We'll make it endeavor number 12 run, right?
Yes.
So I'll need to update online. This will become endeavor 12. I'll input it because we definitely have space in our endeavor cards.
You could put the 11.5 and not have to change anything.
Or you put it 11.
Yeah, that's gross. We have plenty of cards. We have plenty of cards.
Oh, is it?
Ready, set, go!
Really have like 60
Hey, Steve, what was that last one?
12. Okay, you guys try this one using whatever techniques you need. Could be a shortcut, could be a long cut, but solve. Let's solve. If you want to try to use the yellow box, that's the challenging way.
Pass on that one too.
If you want to try to use the yellow box shortcut, that'll be the challenging way. What was that card called? Special improper integrals? Is that right?
Special type of improper.
Okay. Thank you, thank you. Okay. It's nice and legal now. Special improper intervals.
There are 2 12s. I think the old fashioned. So negative 1. 1. Yeah, 1. Carry the negative at all. Look, I did. Got it. Look. Right? That's what you got. You take what you roll, and then you do it.
What would the old-fashioned way say to do?
You don't have to do yourself.
Well, you do have to think you so, but it doesn't end up making a difference.
Because it's only 1 degree.
Negative 1 over minus.
Inside is 1. Inside is 1 minus 0.
Wait.
Look, you'll get negative 1 over. You guys are wrong.
You bounds.
Yeah.
He did use some.
I used to sell those.
She did use some.
I'm doing you sub, but I'm using the yellow box shortcut.
Oh.
Wait, what? I suppose.
Oh, yeah, you could.
Uh-huh.
But it's negative 2.
wanted to do the shortcut,
No.
but why am I still showing it to you? You could have.
Because it's possible.
You would have had to change your U bounds, but the struggle is, what would happen right here that I now need to do in order just to even solve this guy?
Split it.
Why would I have to split it?
Add zero.
We got a
Zero
zero.
doesn't exist.
Because I need to take the limit as A approaches 0 from, wouldn't it have been easier just to solve it outright in the beginning?
Yeah.
Probably. How would you guys have integrated this guy from the beginning?
Make it 2, I'll move to the top, make it negative 2, then you just integrate that negative to the actual.
Oh, I still used U sub.
Yeah.
I rearrange.
Yeah.
Is that okay?
Yep.
Except the struggle is, if you did do U sub, what would you have to do?
Yeah, switch balance.
Would you have to switch the bounds?
Nope,
Yeah.
that's all you have to use.
Unless, couldn't you have forgotten the bounds for a little while?
That's what I
You
did.
couldn't you have done a negative 1 over x minus 2 and then brought back in the bounds? And then you're like, okay, yay, I will do 1 to a. That probably would be the easiest way without having to consider the 0. Anyway, all things considered, guys, homework is due tomorrow. Let's see how we do. Toodles. Because we've taken 2 days on it. We're done. I just didn't find my red marker to put tomorrow. Bye, done.
For my spot check. I don't think so, I hope not. Wait, stay your store free.
Oh no, we should sue.
那你把翻过来，你把翻过来，我能打开看。我不能打开，随便。